For centuries, the Maya civilization hid some of its greatest cities beneath thick jungle canopies. Stone pyramids, ceremonial plazas, and complex road networks slowly disappeared under vegetation, leaving only fragments behind for archaeologists to piece together. Most rediscoveries followed a familiar path: expeditions, excavation permits, and years of fieldwork. But one ancient Maya city was found in a very different way, not by a seasoned archaeologist, not by a research institute, but by a teenager using math. This story begins not in the jungle, but in a bedroom where a young student was fascinated by space, patterns, and the stars.
Behind every moment lies a scientific wonder. I'm Kale, and welcome to SciCurious, where curiosity meets science.
The Maya were master astronomers. They aligned temples with celestial events, tracked planetary cycles, and embedded astronomy deeply into their urban planning. Their cities weren't placed randomly. Many followed geometric and astronomical logic, relationships between stars, cardinal directions, and sacred numbers. While studying ancient star charts and Maya codices, the teenager noticed something strange. Certain known Maya cities seemed to match specific star patterns in the night sky. Not perfectly, but closely enough to raise questions. Then came the key insight. If ancient cities were laid out to mirror star configurations, and if some stars in those patterns didn't yet have matching cities on Earth, then something might be missing. Using coordinate geometry and spatial mapping, the teen overlaid star maps with satellite images of the Yucatan Peninsula. Known cities lined up. Known temples made sense. But one star position had no known archaeological site. Instead, the satellite image showed only jungle. No roads, no ruins, no obvious signs of human construction, just green. But math doesn't care about appearances. The team calculated distances, angles, and relative positions between known sites. The numbers were too consistent to ignore. According to the mathematical model, something should be there. So the question became, was this just coincidence or evidence? To test the idea, the team used publicly available satellite imagery, including infrared data that can sometimes reveal subtle changes in vegetation. Dense jungle often hides stone structures, but plants growing over ruins behave slightly differently than those growing on untouched soil. And there it was. Faint rectangular outlines, unnatural straight lines, shadows that didn't match the surrounding terrain. Not proof, but enough to justify further investigation. The findings were shared with archaeologists. At first, there was skepticism. Archaeology has a long history of bold claims that don't survive scrutiny. But when professionals examined the coordinates and imagery, they saw the same anomalies. Ground surveys followed. What they found confirmed the math. Beneath the jungle were the remains of a previously undocumented Maya city, complete with pyramid foundations, ceremonial platforms, and an urban layout consistent with known Maya planning principles. The discovery wasn't just exciting because of who found it. It was revolutionary because of how it was found. This wasn't luck. It wasn't guessing. It was pattern recognition, geometry, and critical thinking. Modern archaeology increasingly relies on tools like LiDAR, satellite imaging, and computational models. But this case showed that even without expensive equipment, the logic of mathematics can reveal what the eye cannot. It also highlighted something important about the Maya themselves. Their cities were not chaotic. They followed rules, cosmological, mathematical, and symbolic rules, that can still be decoded today. And it reminded the scientific community that innovation doesn't always come from experience alone. Sometimes it comes from asking questions adults stopped asking. What if the map isn't complete? What if the pattern isn't finished? Today, that rediscovered city continues to be studied, adding new data to our understanding of Maya civilization. And the teenager who found it became a symbol of how accessible science can be when curiosity meets logic. You don't always need permission to explore. Sometimes, you just need a good question and the courage to follow the numbers. So here's something to think about. If ancient civilizations left patterns behind for us to find, how many discoveries are still waiting, not underground, but hidden in data we've already collected? What other mysteries do you think math could help uncover next?
Science is everywhere if you just know where to look. Thanks for watching SciCurious. Until next time.